I'm Steve Belcher from Revolution Analytics, and I'd received an email from our user group to see if I had any interest in presenting today. So I said, sure, be happy to come in. So I do work for Revolution Analytics. A couple questions for you guys. Who here is an R programmer? Most people, great. Who here has heard of Revolution Analytics? Oh, okay, all right. Oh, very good. Who here uses Revolution Analytics? Okay. Well, that's not as good. You should all be using Revolution Analytics. So what I like to do is, primarily in the time that I've got left, I really only created a small demo anyway. So I'm going to show you some software, but what I do want to do is just a couple slides to tell you who we are and what I'm going to show you. So I do this with full cognition and knowledge that I don't want to be a commercial. You didn't show up for a commercial Sunday morning. But I've been working for Revolution Analytics for a year and a half. So we do produce a distribution of the R programming language. We've been around for a number of years, and I met one of the original founders here today, which I'd never met him before. And but we're privately held. So the reason I asked for the hands earlier was because a lot of times when I go to a public venue like this, a lot of people haven't heard of us because we are a pretty small company. We've got fewer than 100 employees. But we have been around for a number of years, since about 2007, 2008. Because we've been around for a number of years, and we do have quite a few customers in a lot of different vertical industries. As you know, R is a general purpose programming language for analytical purposes and visualization purposes. So it does appeal to a lot of different industries and problem domains. And by the way, if you have any questions, I don't mind if you interrupt me with questions as I go. I'm used to that. I work in sales, and I've worked in data mining for about 17 years for a number of different companies, mostly in the area. I'm from New Hampshire, so I've worked for companies like Unica, and Aprimo, Epiphany, Portrait Software, which was right here in Boston, KXEN, and now Revolution Analytics. And again, what we do is, and we're growing by leaps and bounds. Business is very good right now because we're at the intersection point. We produce an R package that is very high scale, so it appeals to R programmers and people who are interested in working with big data. And by the way, this is an abbreviated session of slides I often show to our customers and prospects, so I'm kind of skipping over a lot of detail here. But again, if you have questions afterwards, feel free to reach out to me. So as Nick was mentioning earlier, R is great, but it does have some serious limitations. And the previous speaker actually did a nice job with some of the parallel stuff he's been doing with the do parallel package. R does not run in parallel by its, the way it's built. It's also limited by memory. So you guys are R programmers, so when you read data in, you read it into a data frame, which exists in memory. You do analysis on the data. That's all memory-based. And as you start chewing up your memory on your machine, R slows down, and then eventually it quits when it runs out of memory space. So we've architected a hybrid memory and disk scalability platform where we read in bits of data at a time from the hard drive, process those, we call those little chunks, and then we go on to the next one. And we run those in parallel. So I've got a 4-core laptop here. So I will actually show this to you running in parallel. And you don't have to do anything. You just call our functions, and it runs in parallel automatically. And of course, we're a commercial software provider. We provide support for our software. This slide really just shows you when you get our product, and again, I know a couple people are already using it, you get a little boost of speed because when we compile the product, we link in some math libraries from Intel. That boosts certain operations, not all of them, but certain operations. That's kind of a side benefit of buying a product. What we've done and what really people buy our product for is we've taken certain operations in open source R that our customers have said, hey, we've got to do these day in, day out. We need them to run fast and at scale. We've rewritten those in C++ to run very fast, to run in parallel, and to run against little chunks of data streaming off the hard drive at a time. This is a list. It's pretty comprehensive. I should mention, again, if you're not too familiar with us, we're at version 7.2 of our product, which is what I'll show you. So this list is current as of version 7.2. What's interesting from the previous speaker, one of the last things he did is he actually mentions one of the new algorithms we're adding to 7.3, which will be out in October, which is a stochastic gradient descent boosted tree. And we're kind of designing version 8 for next quarter, Q1 in 2015 right now. So we're trying to, point being is we add more and more algorithms with each release. For those people, if you don't see your favorite algorithm, we've got some building blocks called data step and exec that allow you to actually build out your own algorithms in our ScaleR library if you have some favorite algorithm that's not listed here. Quick benchmark. Here's actually a comparison. UE showing GLM-net. This is GLM, the blue line. The red line is RxGLM. So RxGLM is the ScaleR version that we rewrote in C++. GLM is the open source function. Notice GLM, as you add more and more records to the modeling file, it shoots up like a straight line, meaning it eats, as you start eating up more memory, it slows down. And then it quits when you run out of memory. ScaleR won't quit on you. No matter how much memory you have, no matter how much data you're working with, it'll keep cranking along until the job is finished. It will take, of course, more time if there's more data. We usually say about twice as much data means twice as much time to process, but it will keep processing. And this is really just a list of some of the platforms we support. So I don't know what your platform you were running on. Actually, you were running on PCs or? Oh, SunGrid. Okay. So we run on PCs, Linux. We run inside of Hadoop. So we run inside Hortonworks, Cloudera, MapR. We run inside the Teradata database. We run in Platform LSF and Microsoft HPC cluster, as well as a variety of, again, Windows and Linux implementations. So enough of slides. Let's look at the product. So this is our product. Can you see it okay from where you are? Fairly well. What I really wanted to do is kind of show you, again, if you haven't seen our product before, what I usually do in a demonstration is give you kind of a feel for how fast the product works. Now, I've never done a demo running just on my battery, so I don't know how fast this is going to be. A lot of PCs slow down. They slow down the processor when you're running on battery, so we'll see how fast this works. But what I want to do is show you a little bit about how the ScaleR library works. And like I said, you do have to call our function library, ScaleR, but you don't have to do any implicit, do this, do that, a bunch of function calls to say run in parallel. It does it automatically. So I have a standard demo that I have. And maybe you're familiar with the data that we're going to use. I'm just going to run the first couple lines. And again, since you guys are familiar with R, you've probably seen either this type of an integrated development environment or IDE, or maybe use RStudio. It's basically the same thing. I have RStudio on my machine as well. We don't really care which one you use. But what I want to do is there's some public domain data set that's used in a lot of statistical competitions. And a lot of software vendors like to use it to demonstrate their software because it's big. I don't know how sharp your eyes are, but I've got a file on my hard drive of this airline data. It's got all the airline takeoff and landings for about a 22-year period in the US. It's a 13 gigabyte file on my hard drive. Now this laptop only has 8 gigabytes of memory, and I'm running my product. Of course, operating system uses a little bit of memory. I've got a PDF running. So I'm not even using 8 gig of memory. I don't have that available to me. But I can run and process a 13 gig file pretty quickly, no problem on my hard drive. What was the other thing I was going to mention? Oh, the other thing is, again, if your eyes are sharp, you might notice the file extension is an XDF. XDF is our proprietary file type, which stands for an external data frame. Again, the notion here is that with our package, you don't work with data frames, you work with data off the hard drive. And XDF is our, as I mentioned, is our proprietary file format. Very compact binary format, works well with processing chunks. The question you may ask is, do you have to use that? The answer is no. However, the recommendation is yes, if you're going to use the same file to analyze repeatedly, it is more efficient to use our format. But as I said, you don't have to. We will run off of text files, SAS files, SPSS files. You can pull data out of a database. And like I said, there's a number of platforms we run in natively. OK, so what the heck does this data look like? Let's take a look at it. Let's run a couple commands. So the first command here is something called rxgetinfo. So let me just go ahead and hit the run button. So it's already run. This runs very fast because it runs off the, it just grabs metadata from the file. And what it's doing is it's getting me some basic information about the data file. This file has 123 million records in it and 29 columns. And I'd asked for the variable information. So each variable is listed in my console window, things like year, month, day of week, departure time, arrival time, departure delay, arrival delay, carrier, origin, destination, all kinds of neat data that's a lot of fun to play with. As an aside, one of my colleagues uses this as for training when they train our customers on the ScaleR library. What they do is they analyze the data using more functions than we're going to look at today. But they find out if a pilot takes off late, they fly on average 2 miles an hour faster to try to make up that departure delay and arrive more closely on time. And I'd also, as part of my function, asked for the first 3 rows. And so at the bottom of my file or console window, I've got the first 3 rows listed here. They wrap from line to line. But again, this rxgetinfo was just said, hey, let me take a quick look at the file, what's in there. One of the things I make mention of, you might have noticed already, most of our functions begin with the letters rx as a prefix. Makes it easier to find them in your list. Rx originally stood for a remote execution. So let's do some other functions. So we know that there's some airline data in here. Let's run the next command, rxsummary. So you guys have all used the summary command. Is that a question? No, just a stretch. OK. You've all used the summary command. It's probably the most common command in open source R. You can pass rxsummary and get whatever information you want on whatever you're passing. It's got different method implementations for different objects. In this case, I asked for information on these 4 variables, and it went through and ran. And so I've got my basic statistics. So it just ran through that 123 million record file on my hard drive, and it got me basic statistics on those 4 variables. Okay. While I was talking, you may have noticed it was chunking. It shows you processing those chunks. Again, I have 4 cores. I have an Intel Core i7 on my laptop. So it has 4 cores. 1 is the master. So there's 3 different cores being used for data processing. And so those are all cranking at a time. Maybe we'd like to do some visualization analysis. Let me just kick this one off. I'm kicking this one off, and I'll talk for a minute. It's a good time to ask questions, by the way. Typically, when I do this part of the demo, it takes about 50 seconds to run this one. This is Rx histogram. So you've used histogram, I presume. So that basically allows you to generate a frequency plot for whatever variable you want to look at. In this case, I've said, let's run Rx histogram, which is the big scale version of that command or function. And it's going to get the frequency plot for me for the departure delay variable. OK, so in a moment. Yeah, question? Can't hear you. Oh, if I shut off the display, you mean? I don't know. I've never done it. but it runs pretty fast even with it. So, and the other thing I should mention, because that's a kind of a good lead-in question, the same code, that same RX histogram code runs unchanged whether you're running on the Windows platform, Linux, Platform LSF, Microsoft HPC, inside MapR, Cloudera, Hortonworks, Teradata. Doesn't matter, that same code runs. Yep.
What if you try just running the regular histogram? Or will it know that? What will happen?
Couple answers to that. It was a question about using the open source version of histogram. Number one, the open source R version of histogram doesn't understand our file format. So I would have had to have read the data into a data frame and then passed the data frame to histogram. If I had done that with this file, it would crash because it's just too big. It's 13 gigabytes, and I've only got 8 gig on my machine, and I don't have 8 gig really available to me. I probably have 6 or 5. I'm not aware of those.
There are other packages
that
allow you to use the disk.
Yeah. I can't say because I'm not familiar with those packages do. What I will say about this is, again, the processing is actually going on in memory, but what we're doing is instead of with open source R where you all have to read all the data into a data frame to process it, we pull in a little chunk at a time that fits comfortably in the memory you've got available, and then send it over to one core. That core processes it, and then we go grab another chunk. And then, of course, we can scale that across the different.
Do you have a benchmark with an implementation?
Do parallel maybe. Data tables I'm not familiar with. But I was going to say something else about that. I lost it. It's probably because it's Sunday morning. But yeah, no, I'm sorry. We're kind of a small company, so sometimes people ask for benchmarks. Like, there's so many different open source R functions out there. We don't have comparisons against all of them. Some of them, and actually this guy over here, I just bet.
Data table's not going to do everything that you're doing here. I mean, you'd have to do data table, pull in a big memory package. But could you craft together your own homebrew solution? Sure, it's open source, absolutely. I mean, I don't particularly like data table because it has its own syntax as well. But does it read in files blisteringly fast? You bet it does. But you can always do your own homebrew solution. Yeah, I mean, that's why people call me. To do exactly what he's doing would be a little bit of work.
Yeah, I point him out just because he was kind of one of the early guys, so he's probably familiar with some of the early days that I'm not aware of. But we are a member of the open source R community, so we've developed things and added them to the open source library. So if you're familiar with a package called R Hadoop, we wrote that, and so we've made that available as part of the open source libraries. That was one of our early Hadoop implementations. Again, we've gone beyond that with kind of what we've done with the in Hadoop processing. Okay. Yes?
How do you get the XDF format of the file? So if you have data and
Yep.
text files.
Yep. We've got a function called RxImport. RxImport allows you to import a variety of different file formats, like a text file or a SAS file, SPSS file, Excel, whatever. And then when you do that, you can export it as an XDF if you want to do that. Good question. So my RX histogram did run, and I'm just going to finish up here in a couple minutes to be on time. You'll notice the histogram on the right-hand side, and actually it ran about the usual time. So I guess my machine, I think there are energy settings you can do to your machine, so it must not have stepped down the processor because it's running on battery. But I'm putting my mouse pointer where 0 is in my frequency distribution. So again, this is a departure delay. So most of the occurrences of departure delay are at 0. So that's a good thing. Most people did not have to wait for their flight to take off. It took off on time. Sadly, some of the people did have to wait. This scale is in minutes. So there are, some people had to wait hundreds of minutes or hours for their flight to take off. So that's unfortunate, but it's happened to all of us. I've got some other ways of looking at the histogram. I'm not going to look at them because I'm running out of time. I just want to run 2 more commands for you, and then I'll call it a morning. But correlation is one of the most common functions people want to run. So I'm running correlation to see RX correlation, the big data version of it. Is there a correlation between arrival delay and departure delay? And yep, there is, 0.87. So they're very highly correlated, which makes sense. You figure if you're going to take off late, you're probably going to land late. Knowing that, I bet I can build a pretty good model. So I always like to build a model as part of my demonstration. So let me go ahead and build a model for you. And this only takes a few seconds. I'm going to build a linear regression model. So again, if you've used open source R, you've used LM. LM is linear regression model. The ScaleR version of linear regression is RX linmod. So the parameter list is pretty much the same. You pass a function, you pass the data source. And so it's going ahead and it's a simple one. We're just going to predict arrival delay as a function of departure delay using my XDF file. One note, just full disclosure, I'm using the row selection command in here. That's an optional parameter. It's like a where clause in a SQL command. So it's basically saying just grab the records that meet this criteria. And I'm doing that to eliminate outliers. I'm getting only records where arrival delay is greater than 0 and less than 800 minutes. My linear regression model is done. And so because I eliminated outliers, it ran against 58 million records. I've got my intercept term, my coefficient for departure delay, some other standard statistical information that's output, including R squared. R squared is very high, 0.82. I come mostly from the area of marketing automation. Most of those vendors I mentioned earlier were campaign management and marketing automation vendors. So I'm typically used to response models where your R squared is less than 0.10 or something like that. So that's very high, but we know those variables are pretty highly correlated. So anyways, I don't want to eat into the next guy's time, so I'm happy to take any questions if you have them. We've only scratched the surface of what you can do with the ScaleR library. The point being here is that we just want to take a quick look at it and give you an idea of how scalable it can be with the data that you work with. Questions? Yes?
Where did you get the data for the?
There's a lot of sources on the internet for these type of data. You can actually grab that file off of our website, which is revolutionanalytics.com. And we've got a number of data sets available up there that you can download. But if you go to like KD Nuggets has got a million sources or links to other data sets as well. Yep. Yeah, there's an RX data step command that allows you to do a lot of cleanup, conversions. You can actually output new XDF files, or you can output data frames, or you can take a data frame and convert it to an XDF file. A lot of different things you can do with it. Yeah. I'm not a heavy-duty engineer, so I'm not sure I know what the difference is between those. They will. No, it's only for the processor. So good question, because the function library is actually smart. So it knows the underlying platform it's running on. So on my laptop, it knows to use the cores I have on my laptop. If you were running on, let's say, a 100-node Hadoop cluster, it would know to run in parallel across all 100 nodes on that cluster. Yep, yep. Yep, automatically. Other questions? All right, thank you very much.